Oil production and processing technologies in current conditions result in the inevitable generation of various types of stable oil and water emulsions and complex emulsion suspension compositions. The time of easy oil has long since gone. The increase of water cut in oil wells, the rise of the share of heavy and difficult oil results in a significant increase of the water cut, up to 90–95% in the fluid produced. Traditional crude oil dehydration and desalination processes, demulsification of crude oil and water emulsions, don't always remove enough hydrocarbons from produced and wastewater. This is a result of inversion of the emulsion phases and their stabilization due to the chemical reagents used and high quantities of final dispersed particles, SSPs and CSPs present. Experience shows that wastewater may have the hydrocarbons content as high as 10 to 15%. Removing petroleum products and SSPs from this contaminated wastewater isn't just necessary from the environmental safety point of view, but is also economically advantageous since it brings extra profit through increased production and cutting costs. With this, you get more crude oil. You get clean water, free from petroleum products and solid particles. This water can be used for injection in the formation pressure maintenance systems. Injection of contaminated water, oil and water with solid particles, into a formation results in clogging, colmatage of oil-bearing capillary channels, reducing the efficiency of production and oil recovery of formations. So, we have encountered the need for additional separation of stable oil and water mixtures, dispersed oil systems. This is a difficult challenge, complicated further by the diversity of varieties of the actual mixture. It is difficult in extreme to break down oil and water emulsions, stabilized by fine solid particles. You have to know how these emulsions came to be, what substances and compounds helped building it. Every case presents diverse processes and compounds. Moreover, in each particular case, we get a unique composition of solid impurities and colloidal additives. These include sand, cement, oxide sinters, and loam particles. All these impurities help the formation of oil and water type emulsions. The diversity of components, differences in structure, composition, and molecular properties of dispersed oil systems forced that today's chemical science look for an universal oil and water emulsion separation method. This method has been found. Here we present a universal integrated action reagent, REKOMIN-M. Added in the needed concentration to the oil and water mixture, the reagent destabilizes the emulsion in minutes, helping the separation of the remaining oil from water and sedimentation of aggregated solid contaminants. Let us review the physical and chemical mechanisms of its action in more detail. This is oil and water emulsion. Oil droplets don't coalesce with each other. Stratification of oil and water is not happening. The emulsion is stable. Why? Each droplet of oil has surfactants on its surface. These substances may either pre-exist in crude oil, for instance, naphthens, asphaltants, resins, or be added at the primary oil and water separation when demulsifying agents are used. Most diverse surfactants and SSP surround the oil droplet, creating the so-called protector shell. The REKOMIN-M molecular structure, however, has its own more active anionic and cationic surfactant elements. Their objective is to knock the competition, any surfactants preventing the droplets coalescing, out of the adsorption solvation shell and replace them there. In this form, oil droplets can begin to coalesce and float up to the surface. Please note that REKOMIN-M is universal as it neutralizes virtually all possible types of surfactants in the protector shell. This makes it capable of breaking most diverse types of emulsions composed of water and crude oil. Emulsions and suspensions, however, are also formed with solid suspended and colloidal particles, SSPs and CSPs. Look, in our picture, they are not only dispersed in water, but concentrated at the interface surface, forming mechanical structural layering, in addition to adsorption-solvation layers, also helping to prevent oil droplets coalescing. This is why one of the key actions of the reagent is to change the composition of adsorption-solvation layers of the solid and colloidal dispersed phases, ensuring the reagent efficacy in a broad electrokinetic potential range of solid and colloidal particles of the dispersed phase. The reagent structure has elements which react with solid particles, giving them a positive or a negative charge. Due to the action of electrostatic forces, differently charged particles coalesce. Special active centers in REKOMIN-M molecules build polymer links and make these coalesced particles bigger, and ultimately this leads to the sedimentation of suspended solids being pulled down by the forces of gravity. What deserves a particular mention is the problem of the emergence of the so-called intermediate phase, a transition layer of varying composition at the oil-water interface. This layer is formed when demulsifying the initial formation fluid. This layer is stabilized very much by the fine solid and colloidal particles, including those of iron sulfide. This is an extremely stable compound, very difficult to break down. It often results in process shutdowns, incurring significant material and energy costs. The universal reagent REKOMIN-M effectively reduces the likelihood of the intermediate phase formation by forcing sedimentation of all SSPs and CSPs in process fluids. Now to summarize. REKOMIN-M has an integrated effect on all the elements involved in forming emulsions, various surfactants, most diverse solid and colloidal particles. Its composition and structure enables the reagent to self-tune to any emulsion or suspension and successfully break it down. Its application doesn't require complicated process solutions and can be built into the existing process without much outlay. The efficacy of REKOMIN-M has been proved by laboratory and field tests. The Tatneft Institute carried out tests comparing the reagent with a number of foreign equivalents including Prestol, FlowPEM and ZTAG. A comparative study with the latest generation flocculant oil brake has been conducted in Germany. The conclusion was that REKOMIN-M is 5 to 10 times more effective in wastewater treatment. Field tests demonstrated a 2 to 8 times improvement in the degree of purification of produced water compared to reagent-free settling. The time needed for wastewater treatment doesn't exceed 10–15 minutes, while reagent-free dynamic settling takes 8 to 10 hours. REKOMIN-M does not affect properties of crude oil produced by advanced water separation. The economic advantages are as follows: 2 to 3 times reduction in reagent costs, just one reagent used instead of several, reduced reagent selection time. Instead of choosing a make and type of the reagent, all you have to do is select concentration. Increased speed and improved degree of water purification, 10 to 15% improvement in oil recovery, 1.5 to 2-fold reduction of energy costs through the viscosity reduction when purifying water, improved oil recovery and injection well timeline, reduced wear and pump equipment, reduced content of abrasive components in the fluid. The reagent application process can easily be built into a current water treatment system. The Tatneft Institute calculations for the returns of the introduction of the REKOMIN-M reagent for advanced water purification showed project savings of $80 per ton of fluid pumped just on the basic indicators, not taking into account the crude oil that is produced additionally. Chemicals produced by the Red Star company offer the effective and advantageous method for destabilizing any oil and water emulsions, solid and colloidal particle water suspensions. The water treated is compliant to the environmental protection requirements, while the produced oil quality remains unchanged. The extra oil produced is nicely complemented by the reduction of costs.